This is the review of the practice test for the physical science final exam. Temperature is a measure of the average what of the particles in an object. That would be kinetic energy. Okay, we measure temperature, or we look at temperature as being the faster the particles are moving, the hotter it is, or the hotter it is, the faster the particles are moving. It works both ways. So something that's very cold, the particles aren't moving very much. That's when you end up with a solid. When the particles are moving really fast, you end up with a liquid or a gas, and the temperature is higher. So that's how that works. That's the kinetic theory of matter. Thermal energy always goes from, well, the way to remember this is that heat or thermal energy always goes downhill. So energy always goes from higher to lower state. So if you put something hot next to something cold, the hotter object will warm up or transfer energy to the colder object until they end up at the same temperature, or it will try to. It doesn't always work, but it always goes from the hotter to the colder, or the higher to the lower energy state. A substance that allows thermal energy to move is called a conductor. That's true for electric energy as well. Things that move readily are called conductors. Things that impede or slow down the transfer of energy are called insulators. But a conductor, so we use metal pots and pans because metal is a good conductor of heat. Convection is the transfer of energy process that's conducted by the motion of fluids. Those could be liquids or gases, which are both considered fluid. So it doesn't just mean liquid. It could be warm air moving to heat up something in your oven or things like that, or just the warm air coming out of a heating vent. That process of the warm air mixing with the cooler air is called convection. Conduction, opposed to convection, conduction happens by contact, so it's a direct transfer, and when we look at it at the atomic and molecular level, what's actually happening is the really fast particles are crashing into the slower ones and transferring their energy, which eventually speeds up the slower ones. It slows down the faster ones as well, but you're actually taking molecules that are moving really fast and smacking them against ones that are moving slower, and that process transfers energy from one molecule to the next. That's conduction, direct contact. Finally, radiation is the transfer of thermal energy by, as the name implies, radiation. So this would be things like microwave or light heating something up. Okay, it's actually waves of energy that are transferring the energy from the radiation to the particles, which makes the particles move faster. This is how a microwave works. Microwaves make water molecules in food move faster, which raises the temperature of the food. That's the way a microwave heats up your leftovers. The transfer of thermal energy cannot happen without particles. This is not true because of what we saw in the last question. Thermal energy can be transmitted by radiation, okay, which radiation doesn't require particles in order to be transferred. If you're talking about conduction or convection specifically, those require particles because it's about the interaction of those particles transferring energy back and forth. But radiation does not take place or need to take place in the presence of particles. The Kelvin scale has no negative values because 0 Kelvin is absolute zero, the coldest theoretical temperature possible. There is no negative Kelvin. The amount of energy it requires to raise a certain amount of substance by 1 degree Celsius is called specific heat. Okay, all different substances have their own specific heat. So a low specific heat would be things like metals that you can raise the temperature easily. High specific heat would be things like water, which it takes a lot of energy to heat up water. If we were talking specifically about water, then you'd be looking at the calorie. A calorie is the specific amount of energy it takes to raise 1 gram of water 1 degree. So calorie is specific to water. but the term specific heat could be used for any substance. So that's what this question was asking. The difference between Kelvin and Celsius scale is 273. So Kelvin minus 273 equals Celsius, or Celsius plus 273 would equal Kelvin, either way. But the difference is each degree Celsius is equal to one increment on the Kelvin scale. It's just they start in different places. At absolute zero, particles will have zero motion. That's the theory, because we go back to the first question. Temperature is measuring the motion of particles. So zero temperature means zero motion, which is also why there's no negative Kelvin, because if you think of temperature as being movement, once movement stops, you can't have lower temperature because you can't have less than no movement. Substances begin to change from a solid to a liquid. That is known as the melting point. Okay, so you're going to want to know all these phase changes: melting, evaporation, freezing, sublimation, deposition, condensation. Okay, what those all mean, changing from one state to another, solid to liquid to gas and back. Those are all the changes that you'll need to know. We covered this a little bit in an earlier question. Thermal energy always moves to the lower temperature area, right? Lower energy goes from high to low, always. Thermal energy, how heat moves and work, is known as the law, or laws, really, of thermodynamics. Thermo meaning temperature, dynamics meaning change. The concepts, or actually the laws of thermodynamics, were summarized by Newton's laws of thermodynamics. When things get colder, they get smaller. That process is called thermal contraction. The change in substance from a liquid to a gas is known as, should have been more clear about this, you could have said either evaporation or boiling, and you would have been correct. They both fall under the umbrella of evaporation. Evaporation is any change from a liquid to a gas. Boiling is a specific point on the scale, right? If you heat something up to its boiling point, it evaporates. So in this case, either one of those would have been correct. On the actual final, it won't be ambiguous like that. It'll be a definite answer about boiling, freezing, sublimation, one of those. Going from a gas directly to a solid. So this is not condensation and then freezing. It skips over the condensation and goes from gas right to solid. That process is called deposition. Not a lot of substances do this, but certain things like dry ice, like carbon dioxide, iodine would be another one. They don't have a liquid state under normal conditions. They go right from solid to gas and back. A substate of matter with neither a definite volume nor definite shape, that would be a gas. Right? Gases can be expanded or compressed, so they have no specific volume. They can change shape to fit any container, so they have no specific shape. So solids have definite volume and shape. Liquids have definite volume but not definite shape, and gases have no shape or volume. So definite volume, but a definite and a definite shape, but no definite shape. Sorry, has a definite volume, does not have a definite shape. That's a liquid, right? Because liquids will fill around and change shape depending on what container you put them in, but you can't squish a liquid, and you can't put a half gallon of water into a 1 gallon bottle and have it fill up the bottle suddenly, take up a gallon of volume. It's still a half gallon. Most matter becomes less dense or expands as you heat it up, and condenses or gets smaller as you cool it down. The exception to that is freezing water. Ice is less dense than liquid water. That's a very rare circumstance, but if you think about it, ice cubes float in water, even though they're both made of water. And that's because when water freezes, the molecules actually form a sort of a network that ends up with a bunch of empty space in it, so it expands as it freezes. Most things, when they freeze, they become more compact, they condense or compress. An ice pack makes you feel cold because it does what? It absorbs energy, right? You might think, it's kind of weird, you might think that an ice pack makes you cold, and in a way it does, but the way it does that is because when you put a cold ice pack against your body, remember heat goes from hot to cold, so what's actually happening is your body is trying to warm up the ice pack. So the energy is going from your body to the ice pack. It's not like cold is coming into your body, it's actually the heat leaving your body that makes you feel cold. So ice packs absorb energy. The smallest part of an element that has that properties of that element is what's known as an atom. Right? If you break up an atom, then it's not an atom of that element anymore. You might end up with a smaller atom that's some other element, but you can't break an atom of an element into anything smaller without altering its properties. Mixtures can be elements, compounds, homogeneous or heterogeneous. Well, they can be either homogeneous or heterogeneous. Mixtures are not. They could be made up of elements, but elements are not mixtures and neither are compounds. Those are both examples of pure substances. Matter has blank properties that can be used to identify it. It has both physical and chemical properties. Physical would be things like color and density. Chemical would be reactivity, things like that. So we can use the combinations of physical and chemical properties to identify unknown substances.